It's nice to be back at DConf. So before starting, I just want to ask a question. Is there anyone here who has never made a pull request to the compiler? Please raise your hand. Okay, but are there any people who have made between 1 and 5 pull requests? Okay, so the first thing I'm going to say is that there's a human resource shortage in the compiler, which I just demonstrated right now. And I just wanted to share my experience to all of you in hope that this will help future contributors accommodate more easily with the code. And also, I want to propose a list of things that we can do as a community to make it easier for others to contribute. So let's just take a step back here and ask ourselves, why do people want to contribute to open source software? Of course, I haven't read any studies about this. I don't even know if there are. But I did a little research on internet. I just Googled, why do people contribute? And even though I haven't, let's say I haven't read a representative sample of the documents which talk about this subject, there are 2 things that come up very often. One of them is that people want to improve their skills. So contributing to open source software is a great way to, let's say, contribute to a project which is real life and which helps you develop your skills. And the other thing that came up very often is that people want to contribute to projects that matter. Projects that are used. Nobody wants to write code that is never used anywhere. So I can tell you from my experience that contributing to the compiler is surely going to improve your skills. You have algorithms, data structures, and a lot of cool stuff. So, and also, given the fact that the D language, according to the TIOBE index, is in the top 25 most used languages, it certainly has an impact if you contribute to the compiler. Still, people do not contribute. So, why is that? First, let's take it in general. Why would people not contribute to an open source project, not DMD in particular? Also, I read some blog posts about this which are literally entitled, "Why do I still not contribute to open source?" And most of them were saying that they don't know where to start. So let's say you want to contribute to an open source project, but it's not really clear on what bugs you should work or what projects you should tackle. So not knowing and not being guided what to do is a major turnoff for most people. And the other fact was that people feel stupid when they contribute and their work is being rejected. So what we can take from here is that we need to guide people on what to work on in the compiler because there are a lot of stuff that needs to be done. And also we need to guide them to some projects that match their level of experience. For example, if someone does not have any experience with compilers, we must guide them to do some work which does not require that much experience. And there are projects in the compiler where you can do such a thing. So, continuing, I just want to talk a bit about the phases of contribution. So, in my opinion, there are 3 phases. The first one, even if you're trying to solve a bug or try to add some new cool code, you have to find how to integrate your code with the existing code. Then, you have to understand what the code does, also the code where you want to integrate your code, and also the code you want to use, because you're probably going to use some functions from the existing project. And finally, you will write the code. Now, most programmers will want to write code and don't like spending time in searching for the code or reading a lot of code. So what we must try to do is minimize the time spent on searching the code and understanding what the code does, and let programmers do what they know best, and that is actually write code. Now, I want to talk to you a bit about my first experience with DMD and how these 3 phases applied. So, I first tackled the header generation issue. So basically, you had this code where you had a ref method which returned AA, and you wanted to use this command to generate a header file. Now, you would expect that the generated code would look like this. Not blank. Oh, maybe we should just try a reset.
Reset.
Sorry, P and what? Apparently, spending too much time in the compiler is also not so helpful. Thank you. Okay, so you would expect this code. Now, can anyone tell me why is the function body put here in the header file? Yeah.
Because without a return type, this is an auto function, and an auto function needs to have the body for the compiler to be able to deduce what type it returns.
Yes, you are correct. So in the header files should be compilable D code. So if you would just generate this code, which that was the case, this code is not compilable because the compiler cannot deduce the return type here. So what I had to do is basically locate the code where the header generation is done and check for the return type. And if the return type was null, then I had to generate the body. So sounds pretty straightforward, really simple. But take into account that that was my first encounter with DMD. So I had no idea about the organization of the code, and only the front end is spread across 163 files. So I had a pretty major issue on locating the code. So my first idea was to rgrep after -h. This didn't lead to any results because I later found out that when the command line switch is parsed, they only check if they eliminate the minus and just see if it's an H. So I couldn't search after H because obviously that wouldn't have gotten me any answers. Then I thought maybe I should search for the entry point because then I'll see the code where the command line switches are parsed. I rgreped after main, but still there were a lot of results, so I couldn't even identify where the main function was because it is called mars.d, actually, how I found later. So after a few hours of searching the code, I finally gave up and asked Andrei, where is the code? And he showed me that. So I started going to the next phase in understanding the code. Now, in this particular case, it was pretty easy to understand what the code was doing, but it was really hard to know what functions I had to use. I started looking in the function declaration AST class, which in my opinion is the natural thing to do, but there were a lot of fields. I didn't actually knew, neither one was named return type or something, so I didn't know how to do. I cropped some sort of solution there, but it was obviously not the right one. And I wrote it, I submitted a pull request. Of course, that broke some tests. And after a few rounds of review, someone pinpointed, actually it was Stefan who pinpointed what the right solution was. And all in all, I spent like a few days on that bug, which is a pretty simple one. Most of the time I was searching for the code and trying to understand that. I literally spent like 1 minute writing the code, and still it was the bad solution. So after this experience, I didn't feel that I learned anything. I felt that I mostly lost time, and I was feeling pretty frustrated. I was feeling stupid, and maybe if I wasn't so committed to DMD, I would probably might have quit. So the following photo pretty much summarizes what I felt for my first contribution to DMD. So after repeating this process for another 3 or 4 times with other bugs, nothing changed, but then I finally got to work on my first project, which was DMD as a library. Now, this was my last year DConf talk, if any of you remember, so basically I had to template the parser in order to create an isolation between the parser library and the rest of the compiler, and for this I had to create AST families, create visitor classes. All in all, I had to do a lot of refactorization and a lot of moving of code from one point to another. There weren't so many, I didn't have to write too much code. I basically had to move. But the upside for this was that I kind of got a good overview on the location of the code. So now I had let's say, a basic idea on in which files to look in order to find the code that I needed. And also, I got to see how the AST is organized. Basic knowledge about the AST, so nothing too complicated. But then I noticed I was still doing bugs in this time, and I noticed that the time spending in identifying the code got smaller and smaller, and also the time needed to understand the code got smaller. I was still pretty much losing time in understanding the code, but all in all, things were going. So I felt that I was learning something, my productivity increased, I started feeling positive emotions, like that I'm learning and things are going. So this pretty much summarizes what I was starting to feel about DMD. Now, this is very important because this is what we want people to feel when they contribute to DMD. Now, after I got, let's say, a basic understanding on what the code does, I tackled my next project, which was Lambda Comparison. Now, to give you a bit of context about this, I'm not going to delve into the details. You can do this online, because I'm pretty short on time. I'm going to assume that everyone knows about the infamous Lambda string functions. There's been talk for, I think, 5 years of deprecating them. But the thing is that they have, there is one case where Lambda string functions are actually useful, and that is for function comparison. So in Phobos, there are some algorithms which basically benefit if you know that the predicate is a certain predicate. And as you all may know, function comparison is an undecidable problem. But in this case, for these simple functions, you could actually do a string comparison and see if a function, for example, is the equality predicate. Now, what is the problem with this? This is the only way we can do function comparison. That was the only way we could do function comparison at that point. But it is a bit flawed because, for example, you can use only A and B. You don't have any information about the context. Also, if you put a space right here, then if you compare it with an equality predicate, it's going to result false, although it's basically the same code. So given all of this fact, the Lambda Comparison project wanted to use the AST knowledge via the traits is same, so that you could actually compare ASTs with, let's say, alpha renamed variables and so on and so forth. So this is pretty much, it is a very powerful method, and it kind of lets room for a lot of improvement. So this is basically a whole field of research. You can do a lot of stuff. You can use context, and the comparison is more reliable. So basically, the first implementation was pretty simple. You just have to serialize the AST and compare the serialization. Again, we can talk more about this offline if you're interested. But where I wanted to get is that I started writing more code in DMD. And in order to write code, I had to understand what functions it offers. So I spent a lot of time trying to understand what the functions do. And as I've put it here, I gained an advanced understanding of the AST organization. Now that you probably noticed that in the title, in the previous I had where and what, these were basically the two projects that kind of gave me the knowledge in order to go to the project that I'm working on now, which is the postblit qualifier paradox. Now, Andrei talked a bit about this, but he didn't mention that basically the spec says you cannot qualify a postblit. So we get from here that when the postblit was designed, it wasn't designed to work with any type of qualifier. So it would basically define a postblit, and then it would be used no matter if the object is immutable, const, or shared. But in reality, the fact is that you could qualify the postblit, and it actually imposed some restrictions which later on led to undefined behavior in some situations. Not to mention that the whole idea of having a shared postblit is kind of a philosophical question because nobody can guarantee that when you're copying the data, another thread doesn't come and modifies the data. You have to lock it somehow. So since the documentation was really not helpful, I had to document what the postblit does going from code. But now I had the necessary tools to do that. So it was a very hard, but it was a very rewarding experience because then I had to think about all these language design issues and what can we do to make it better. And as Andrei told you, probably the solution is going to be a copy constructor. And what I want you to get from this is that you can do very awesome work in the compiler, but first you have to do, let's say, less interesting projects in order to get the necessary knowledge to do that. So, in other words, this is what you feel when you get to this point. Okay, now, it took me like a year to get the necessary knowledge in order to tackle important problems. But the good thing is that we can reduce this time. And we can reduce it if in my opinion, so this is solely from my point of view, we do some stuff. For example, one is that we should make a DMD source file organization diagram. Now this would point to the users, to the contributors, now where the code is. I'm not actually sure how this should look, but I'm open to ideas. My initial idea was that, yes?
We have a wiki page which shows an outdated version of the organization, which is actually pretty good and which just dedicates 1 or 2 sentences to what each file is at least supposed to do.
Okay, that's cool. Having a wiki page is good, but having links to that wiki page on the starting as a contributor page, or I don't know, in the forums or somewhere where people would actually get to see it, might also be useful. Also, documenting the code. I cannot stress out how important this item is. And I'm not talking just to document your own code. I'm also talking about documenting other people's work. For example, how I got to this point, I'm going to tell you. So I've seen a code, a paragraph of code, which I tried to understand. It took me like half an hour, but there were like, I don't know, 20 lines of code. And everything was fine. Then, after a month, somehow I got to read the exact same paragraph of code, which I forgot that I understood last time. And then I spent another 20 minutes or 25 minutes understanding that piece of code. And when I finally understood it, like, oh, yeah, I read this code before. Now I know what it does. Then, after 3 months, I got to read the exact same code again, still not knowing that I have read it before, and yet again losing time understanding what that code does. So the solution to this, if I had documented that piece of code when I read it the first time, I could have saved me some time.
Well, what we do in DMD is we use Unix-style documentation, which is use the source, Luke.
Okay. Also improve the user specification. Andrei already went through that, so I'm not going to lose your time on this anymore. And also, this I think is the most important part, to create a section which guides first-time contributors on what to work. So let's say you're someone who just heard about the D language and doesn't know what the vision for this language is, or what projects there are in the compiler, but you want to contribute. Well, if you go on the starting as a contributor page, it just tells you how to set up the repo, and then it says, oh, you can just look on Bugzilla. In DMD, there are about 3,000 bugs from which to choose. You have no idea about how the code is organized, what the code does, and you're supposed to select a bug from that to solve. So that doesn't work. So in my opinion, we should have if you're a first-time contributor, we have some small projects which you have to do. you think that you have knowledge about compilers and stuff like that, we have this project which you can take a look into, and so on and so forth, so that people know what to work on. And also, it would be nice to have a dev manual. In my opinion, this would be a game changer. So basically, anyone could learn about compilers applied on D. Because I was a master's student when I started working on the D language. And in my opinion, it's a great language for people to learn compilers on. And it would be an alternative to the Dragon book, to the legendary Dragon book. Well, I know that it's probably pretty hard to do a dev manual, but I think that we should have it as an idea. Now, I just put this slide here for people who want to contribute. So to have in a few steps what they can do. So even if you never contributed, you first have to go on the starting as a contributor and set up the repo. I'm not going to lose any time on that. And also, there's Walter's technical depth list, which you can find at this link. And there are listed some items that we need to do in order to modernize the compiler code base. So at this moment, if you've seen the compiler code, it very much looks like C++ ported to D code. So it doesn't actually benefit on all the cool stuff that D has to offer. And on this list, there are stuff like, let's say, replacing pointer parameters with ref parameters, or applying const, pure, no throw to functions where possible, diminishing the scope of variables. I know that this might not sound very interesting, but it's necessary work which would have a very high impact on the compiler, and also it's a good ramp up for you if you want to be a future contributor. Of course, after that, or if you feel that you are skilled enough to pass this, let's say, this step, there are the Bootcamp Bugs, which, as you've seen, even the most trivial ones can be very complicated if you do not have the necessary knowledge. So after you kind of get used with the coast base and you know how the compiler is internally represented, you can tackle those Bootcamp bugs, which are tagged also because they are simple. So for example, there are some bugs where you just have to modify an error message, stuff that anyone can do. And of course, you have to stay connected with the forum, which is where all the community energy is, where language design decisions are made, where bugs are found, and where everybody discusses. And now to wrap things up, contributing to the compiler is hard work. I'm not going to lie to you. But it is also very rewarding. And I felt that I learned a lot during this past year when I worked in the compiler. And now maybe this will surprise most of you, but anyone can contribute. We do have tasks and that need to be addressed and that people with no experience in developing a compiler can do. And I challenge you that on Hackathon, all of you who never contributed to the compiler, pick one item on that list and make a pull request. And I will personally take care that it gets merged right away. So that is all I had to say. Thank you.